Good evening, everybody. So we've kind of started doing this like once a month
Yep.
live stream thing where we're just going to throw different things out there and try to bring some different perspective. Maybe sometime myself and some other guests, maybe myself and Bill. We'll see how it goes here. But we're going to have a little fun tonight. We got an interesting topic tonight. One we've talked a little bit about. We're going to talk about new product development, and I've got a little bit of experience, and I'll say a very little bit of experience. But Bill, you've got quite extensive experience in product development. You want to share a little bit about what all you've done?
Sure. And thanks, Eric. And this actually came up. We were at the symposium, and there was some conversations with I think one person in particular who had an idea for a product, and we were. I got into conversation with him. I said, "Well, do you realize what it takes to really, make a product for, for general purpose use to sell to people who are going to rely upon it?" And this started the conversation between Eric and I, and we bounced back and forth, and that's why we're here tonight. Is it was decided this is a um, something people might want to hear, and also I think, and we both appreciate this, is that you need to appreciate what goes into a product that you can just rely on day in and day out. So my experience is working in product development. Actually, my first job out of college was with Eastman Kodak Company. I worked in quality control for high speed copier duplicators, which meant I got to see manufacturing, I got to see design. Quality control basically asked a ton of questions, and we did this proofing test where copiers were run 24 hours a day, 7 days a week in altitude chambers. So they were run all the way up to high altitude, 6,000 feet. They were run with high humidity, with high temperature, freezing cold temperatures, just sort of like try to beat the crap out of these to make sure that they just continue to run for customers. So got a tremendous wealth of experience working all the way around that area. Next, worked for Fisher Scientific in developing lab equipment. Uh, and that includes like electronic as well as physical lab equipment. And then I worked 10 years at Backrax. It's a name probably a lot of people on the show know. Backrack Incorporated. I was a design engineer there and developed and got a couple, three patents on different products there, and got to work with a lot of different colleagues from the design development standpoint, electronics, manufacturing. Got to go visit places where they made tooling for products, where they actually made the components. And then when I went to work for Superior Valve for a couple of years, they actually had a factory in Washington, PA, and I was in charge of a business team, a business unit that had a design engineer, had marketing people, salespeople, customer service, uh, and there was a factory like right outside the door where they made all the products. They turned the metal, they brought in the components, they assembled valves for HVACR. And then shortly after that, I worked for Testo for 10 years. And at Testo, I wasn't actually doing the product development anymore, but I was working with colleagues from Germany with their process, and they were very interested, intrigued in the products they could develop for the US market. So thank you for that chance to read my resume.
Well, I think it's important to bring some perspective to this and say that you're not just speaking theoretically here. Like,
No.
you've seen a lot of this, you've done a lot of these things. So there's a wealth of experience there. And I know you and I have talked about this on the side, but it's cool to me to get to like share that
Yeah.
uh, um, part of it out there that maybe a lot of people don't know of some of the stuff that you've done, but share that knowledge and say, because it's fascinating to me. I've been involved in a couple of projects doing some beta testing in the field and giving feedback back to manufacturers and things like that. And it's really fascinating to me, the process and everything that they have to go through, and the some certain products, the testing, and all kinds of different things. So let's kind of dive into this from the beginning. Most products that I've seen start with an idea or a concept or somebody seeing a need for that product in the field. or perhaps even to improve on an existing product that's in the field, maybe to make it easier, more durable, more robust, whatever that might be.
Yeah, there's got to be some point of differentiation. Otherwise, you're just copying. And if you have nothing to stand out above a copy, maybe you can, you know, pull in a slice of the market pie. But you need to understand the needs by listening very closely, um, and the pain points of tech. In our case, we're talking HVAC technicians. Um, what do they need? What kind of tools they need? Where are they going to use them? A big phrase is use case. I think I heard that, probably heard it first spoken by Jim Bergman, talking about how and where a product is used. And I will say, just kind of going back, and you said, yeah, I got a wealth of experience, but it is dated. So I will put that caveat on there. I exited Testo when I entered into TruTech, and that was 2009. So
Mhm.
that's 15 years ago. Sort of some of these things are frozen in time, but I think the approach is still consistent and necessary.
I think a lot of the process, maybe some of the individual things that are done in each step might have changed, but I think the process is probably still pretty
Oh
similar.
yeah, and I think there are new tools, tools, and the costs coming way down, and tools to simulate, tools to model. I mean, when I was working in this area, 3D printing was just crazy expensive. You could get it done. There was a company called SLA, Stereolithography Associates, that used to build up models. Um, and when it was really necessary, you had one built. But now there are people on, Etsy and eBay and Amazon making products that people are buying, and they're making a nice profit out because the materials and the techniques have gotten so much better. Modeling tools have gotten better. The computing power needed to do some of the modeling, like for airflow, or fluid flow. We'll just say fluid flow. Computational fluid dynamics, being able to use equations to model how fluid flows through materials. I'm, I'm not going to say who it was, but I attended a session from one of our vendors, and they were showing the benefits of proper refrigerant tube bending versus using fittings, because the edges of the fittings can make a tremendous downstream effect on the way fluid flows, the pressures, the way thermal energy is conducted. And they modeled this out, and it was just really striking. Why do you use benders? Because benders maintain that smooth inner wall of the tube for the refrigerant to flow over. So that was something I was like, wow, that's cool. I remember that back from Kodak, which used to be a multi-billion-dollar company. Now it's almost nothing, but they would do that. But this smaller company can do that kind of thing.
Yeah, yeah, and that has helped. I mean, the computing power of, things that we have in our hand or maybe sitting on our desk today, 40 years ago you might have had to have like a mainframe computer or something that took up the entire
Yeah.
floor of a building to do that process.
I mean, just look at like Quick Model, Russ King and Connor King's product, and 3D modeling and computation you can do on a desktop. So
Yeah. Yeah.
yeah, but going back, yeah, identifying the market needs and also figuring out where you fit in the competition, see where the gaps are, where the opportunities are. And I will say one thing: I've worked long enough in this field to learn that because you can do something doesn't mean you should do something. Now you're laughing, so does that strike a chord?
It does. It
Okay,
really does. I mean, sometimes I've seen companies do things and I'm like, why?
yeah.
Why are you doing that? Because it doesn't make sense to me anyhow. Obviously they decided it did.
As a recovering engineerholic, I will say that it is, I say, a tendency of an engineer to get wrapped up in a technology and really want to deliver it, but not understand that use case, the needs, understand the gaps, and how it's going to fit in, and how it's going to propagate to deliver. How it needs to be tested, how it needs to be manufactured and sold, because some things are very complex and hard to sell. Uh,
Yeah. Yeah. Well, and
we
that's
had a conversation today where it was, if it's in the right hands, the right user who knows how to use it, they're going to love it. But if you're missing that education step, oops.
Mhm. Yeah, if somebody grabs something and doesn't know how to use it or misapplies it, and suddenly it's oftentimes, kind of like blaming the equipment in an
Yeah,
HVAC system with junky ductwork on it.
yeah,
Um, it's not the product that's failed, it's maybe the application or the use case that's failed. So so what comes next? You got the concept of something, you think it's good to go forward into production, or maybe even try to see if you can produce it. Obviously price is probably going to come into play here somewhere. What can we sell it for?
right.
Is it going to be reasonable? What's the next step?
Well, I think, creating that initial design, yeah, user experience. Thank you, Rachel. That's so important. And creating that initial design, getting it in people's hands and getting it out of your team's hands who have developed it. It's, sort of their baby. They love it. Uh, they'll overlook the warts and blemishes, but you got to get it in the hands of users to say, yeah, this needs something, or it's how to do. So, producing prototypes, but even going back to, if it involves like electronics, to do modeling, like circuit modeling, and to understand which components you're going to use. And then you can start to build up your BOM, your bill of materials, and start to iterate that, and look at the mechanical assemblies, evaluate those, um, to, really see are the features, the dimensions, and materials correct. One thing you mentioned, are you going to be able to sell it at a certain price? Uh, there's a classic process called stage gate process, and they actually used it at Testo. But I mentioned before, I was not in that process, but I was watching that process. But basically, they would have teams of people started, and I printed this out to make sure I got it correct. Um, but there's a discovery stage, an idea screen stage, and as a business owner, you can set like criteria to pass through the stage, and then a gate opens up and you get more money to do the next step. So this is a way of controlling cost overruns.
Hmm.
However, if you sometimes you put those gates up, it can be very frustrating. I know that from personal experience, walking up to that gate and just peering over the side and watching somebody with a dumb idea got through the gate somehow. Um, and you get very frustrated, and that sort of that fluidity and creativity, and I'll say the ability for sort of the aha moment to happen. Sometimes you have to be really far down the stage before the aha moment happens. You said, that's it. And if we didn't go this far and spend this much time and effort and money, we never would have come up with something.
So those gates may be limiting some products as well, is what you're saying there
Yeah.
at certain times. I mean, the gates have to be there, are put there, I guess, to say, is it a good idea to spend this much money on it? Because let's face it, development takes money.
Yeah.
And what would you say the ratio of products that come out, or at least go a little ways down the path from concept to actual products that get produced? What do you think the ratio was on the projects you worked on?
I'm sorry, that's a trade secret.
All right, fair enough.
No, it's got to be different for every company and every design. And sometimes you'll just have a brilliant team that just continues to iterate, tuned in. They've got the right channels to the marketplace. Um, I'll credit Jim Bergman's team at MeasureQuick. It is a product. It's a software product, but they are really tuned into the marketplace. They've got a really great team. They respond really quickly. They have, their customers appreciate what they do, and they let them know when, what they need and where they're headed, and they stay patient.
Hmm. Hmm. So, right now we're getting a little bit deeper in here. We've gone beyond the concept. Maybe we've got a first generation put together, kind of running a little bit in a lab somewhere. I'm going to say on a bench.
Yeah, and Rachel,
Maybe it's a proof of concept.
yeah, Rachel had the comment here, the digital testing in a virtual setting, that is now something that's available at a much lower price point. It used to be that was crazy expensive. But I'll give an example. Like when I started at Bacharach, I was given, they wanted to make a single gas analyzer carbon monoxide, and it was called the Monoxer 2. The Monoxer 1 was little test tubes that stained with a chemical in them, depending on how much CO from how many puffs of the little actuator you made, how much airflow you flowed across them. So this was supposed to be a real-time single gas only CO analyzer. But when they got to the point and looked at the price point they wanted to sell it at versus the component cost, the pump stood in the way. Good, like I want to say it's a vane, like a rotary vane pump. Uh, those were pretty expensive. So the challenge was given to me. Can you create a pumping mechanism that will deliver an appropriate flow rate to the sensor at a lower cost? So I started playing around in the lab with some colleagues, lab technicians, and the modeling shop, and created this little. My boss called it a mixed flow fan, where it was basically uh, like a merry-go-round with little partitions in it, and then the air would enter the low pressure area in the center and then be spun off to the side in a volute to flow over the face of a CO sensor. And all that could be plastic molded. So all you needed was not a pump, but you just needed a simple motor to
Hmm.
spin this little wheel. But we had to figure out the size of those little veins that were put in there, all the depths, the dimensions, how much could it pull against, could it, how much, stack draft could it pull against in order to be able to do an effective job. So we did a lot of modeling of that before we committed to the tooling. And I will say too, this is, self,
Self promotion there.
not self promotion, but this is self opposite of promotion.
Oh, okay.
I was in charge of the project. It was 3 times over cost from my estimate and twice as long to do it. That's the other thing that gets involved, is making estimates and projections of how to do these things. And I'll go step back a little bit to the design and prototyping. You immediately should start, immediately you document. So
Mhm.
you know where you're coming from, where you're going to, you compare your notes. And if you're in a system or a team that's continually developing products, you get better at it as time goes on.
Mhm. I mean, being a one person team, it probably is challenging to develop a product because you don't have competing opinions.
Yep.
You can kind of get in your own bubble, and sometimes that works really well, and sometimes it can be challenging if you're trying to iterate something.
Yeah. Because eventually, the customer has to understand what you're doing, how you're going to use it, that kind of thing.
Mhm.
I get one other point that came up was in terms of the new tools. Today the difference between before and today is collaboration. Fast global collaboration is available today that wasn't available in the times that I worked in this area. So if you can find somebody who can do something for you, and with trust, of course, and with skill, you can get something done. You can have it happen overnight. Something that may have taken um, a while to ship something out. You can send a digital file and have it developed and have it sent back overnight, that kind of thing.
Yeah, I mean, if somebody's doing a 3D print or like a CNC job or something like that, you don't have to have that in house. You could
Right.
just send that to somebody and they drop it on an airplane and you got it in the next day or something like that. However it needs to be, is it's amazing how fast some of the little processes have changed.
And there's the laboratory testing for development. There's the field testing to make sure it works as intended. But there's also things like shipping testing.
Mhm.
I remember the big copiers. They actually, I think they weighed a ton. They were mammoth, really heavy steel framed pieces of equipment. They would be sent to vibratory testing to
Oh yeah.
simulate being trucked to a
Mhm.
site and just try to shake the crap out of them and see what would break.
So I actually, when I was in commercial HVAC, I actually took care of a facility that did that here in Indianapolis, and they were a cardboard company.
Mhm.
And so they would test all kinds of different products. They had all the cutters there and just raw sheets of cardboard to make different boxes and different size packaging and all kinds of things. So we had temperature and humidity chambers, vibratory chambers. It was neat to watch the vibration testers because they would set stuff on there and it would just shake it for it simulate hundreds or thousands of miles going down the road
Yeah.
in a matter of days.
And actually, I seem to recall, like, the place we sent it out at Kodak, they actually put an accelerometer on a truck and drove it around and
Hmm.
said, "We're gonna simulate shipping it to San Antonio
Yeah.
over this highway," and they can do that in a facility.
Hmm.
Um, something back in the design stage is you have to one of the specifications, the needs might be for one might be for being able to assemble it. There's a concept called design for assembly, and you may recognize it. I think HVAC technicians would recognize: is it serviceable? Can I get at things? How are things stacked in there? Um, are they designed to be assembled by a machine, by a human, and then disassembled by people? Um, and are they meant to be user serviceable, or are they meant to be sealed and only serviceable by authorized service? So you have to build those features into things.
Yeah, and um, that's something that as HVAC technicians or a lot of technicians on mechanical things, let's just say we complain about that sometimes because sometimes the design for assembly is not designed for service later.
Mhm.
That that does happen from time to time. Um, so but that's a consideration, and it's something that we don't necessarily think about in the field because as manufacturers they're thinking about, okay, we have to design this to get it through an assembly line and get it out at a reasonable price point because we have
Right.
customers that want it at a reasonable price point. And maybe if we designed it to be super easy to service, it may add 10, 20, 30% onto that price. We don't know. We don't know out here in the field how much it would add on to that price and what it would cost over the production run because um, there's a lot of things that go into that production. But I imagine that, like, if you're talking, when you said development, the one product you worked on went twice as long and three times over budget. How do you recoup that?
Um, Other projects, or you sell a ton of them. And you amortize it over time, and you have some rules on that. Different companies have different rules. um, some of the companies I worked for was um, the projection had to cover the development cost, which would include tooling, which would include engineering time. So all these things are tracked in order to. So it's sort of like if you go from like the selling price, then there's the distribution margin for distribution to be able to do their thing, like we are now at TruTech doing our thing, training, stocking, support, shipping, all that kind of thing. And then there's the cost of goods, which is made up of two things when you're a manufacturer. Usually it's materials and labor. And then once you take the sell price, you take off the distributor margin, you take off the cost of goods, you end up with the net profit. But that net profit is what pays for the development tools. And those development tools include things that, paying the staff to do R&D, uh, paying for equipment, paying for tooling, that kind of thing, paying for real estate, paying for the lab that develops it. So it's a very intricate process.
Yeah, and that's something that really has to go into consideration when you're talking about manufacturing things because that's a long. I mean, you could take years to recoup your costs on some of those products.
Yeah.
So it's a I guess that's a lifetime consideration. How long is this product going to be viable if we produce it today, and how long do we have to make our our investment back, our initial investment.
And then there's the concept of platform products. That can be morphed into multiple versions. You see that a lot in combustion analyzers. You'll look at and see like there's or multimeters. They have the basic, maybe similar size display, similar size controls, similar size board, but when you open it up, the components are very different. The functions and features are very different. Same with combustion analyzers. So those kind of that's the way you can sort of spread that development cost over multiple models and be able to recoup the development costs over more product sales.
Yeah, and we see that a lot in cases. I guess just the form factor of a
Yeah.
case will be the same across a whole bunch of models. Or if you open it up and you look at a circuit board, maybe a basic model and the really high end model, they've got the same circuit board in them,
Mhm.
but they just have fewer components on that circuit board
Yeah.
because it's less expensive to design and print one circuit board than it is to do a different board for every one.
Right. And that will require clever design too,
Yeah.
because you may have to have different routings for the circuit boards and pathways and things like that.
Or you just put jumpers on in some place rather
Yeah.
than an actual component. So,
And I'm thinking right now of my EV, my electric vehicle, which Fisker Ocean One. We could do a show on that maybe. That'd be fun. I was actually on a podcast that dropped today talking about my feelings about the way things are going.
uh-oh.
Adams EVs, I think, or Adams EV reviews. If you look for that, you'll find me on there a couple times now. I've been a guest, but um, there are features that are put out there that are built into the vehicle that can be remotely turned on and off. The
Hmm.
hardware is there, the componentry is there, and you can literally, in some vehicles, buy a service for a period of time as you need it. And it's, like you said, way cheaper just to make one thing
Hmm.
and then to rent out sort of different uh,
So,
aspects of its function.
so they rent you parts of your own car?
They rent you parts of your own car. Yep.
That's
You buy,
interesting.
yeah, yeah. Now, I got the upper end of model, and I got everything, but actually they didn't deliver everything. Again, that's another conversation here. Um, and Rachel brought up another good point about R&D costs for U.S. companies can provide tax breaks because you are investing in, manufacturing. You're investing in the economy. You're investing, sort of for the public good. So
Hmm,
that's a way of, for a company to recoup some of those R&D costs.
interesting. So it pays to be if you're gonna go in and do product development, it almost pays to be a well-organized company
Oh yeah.
and have your ducks in a row rather than just trying to do it. If you're gonna be serious about it, trying to do it as a hobby, I guess.
Yeah, I mean, you can get away with it, and a hobby slash, if it or artisan, perhaps.
Artisan. Yeah.
Yeah, um,
Probably a better term, more accurate term than
yeah,
hobby.
or craftsperson, that
Mhm.
kind of thing. And you also have to have, again, documentation we talked about, and we were talking the other day about this. I remember the days when they would do hand drawings on vellum and then put it through a machine to make prints,
Okay, so
blueprints.
let's back up here. What is vellum?
It's kind of like I don't know exactly what the material is. Somebody's going to look it up and put it in the comments, I hope. But it's sort of like almost like a plastic, but it's transparent, so light can pass through it. So when you put lines on the vellum paper, you can shine a light through it and expose a photoreactive paper to make a blueprint. So the vellum is like the archive copy,
Mhm.
and the vellum material doesn't wear out, doesn't age, doesn't yellow, that kind of thing. But I can remember at Bacharach there was a print room, and there were like 2 or 3 people working in there, and they had stored files and files, flat files in a drawer, and they say, "You need a print of an old part." They would go leafing through a drawer, slide out the vellum, put it into the print machine, push a button, run some paper and chemicals through it, and boom, you got your blueprint. And then they would store back that archival copy. That doesn't happen anymore.
Yeah, that's those drawers, a lot of those drawers are now either in the scrapyard or parts bins in people's shops and
Yeah,
garages.
yeah. There you go. Yep,
Not that I would know anything about
right,
that. All right,
right.
so we got a question here.
What I've been floored at by its development over the years and months. Floored as in positive for its performance or the amount of time it took to develop.
Okay, here we go. So positive, yes, maybe rapid pace of development.
It's hard for me to say because at Bacharach, things moved at an appropriate pace, put it that way. At Testo, they had a much larger suite of engineers. They were much more thorough, so they were quite a bit faster because it sort of had like a bigger engine to run things through. Um, I'm not coming up with anything.
Hmm. Okay, here we go. Like smart probes and how they've
Oh,
evolved or not evolved as fast.
okay. So I think
So that's kind of like a class of tools then.
sure. Okay, now I get it. So smart probes, test. I think Testo was the first ones out there with smart probes, and they did it as recognition that the price points were kind of high in these units, and they recognized after iPhone started coming out, Bluetooth connected things that they could do this connection and deliver some information through an app to a device. And then there's no, the interface is something the user owns. The display is something the user owns. And all you need to do is provide what I call a radio probe or a radio sensor. So a sensor with some conditioning electronics to deliver a data stream to a device. Um, Testo had the first ones out there, as I recall it, and they had a limited selection, and then they grew that selection, and then other competitors started to move into that market because they did strike a chord. They did their research. It was portability, um, basically cordless and being able to sort of like have being able to measure differential humidity across a system to get the enthalpy change.
Do
It
you
used
think
to take two probes, running it back to a meter and doing the calculations, and now you just put these two probes in and press a button, it's there in your hand.
now I'm remembering back because this is actually, this whole iteration's actually in my time in the industry
Good.
as well.
Mm.
Um, did was Testo first out, or was that the iManifold that first came out with the wireless probes? I'm going to say wireless probes because I don't want to say Bluetooth because iManifold was not Bluetooth. They used the
Zigbee.
Zigbee connection, and then had, because at that time Bluetooth was really short range. The
Yeah.
early Bluetooth stuff, like if and some of you may remember this, like if you put your phone on your right hip and your earbud in your left ear, you didn't get Bluetooth signal because your body was in the way.
Yeah.
Like you had to have them on the same side of your body. And even sometimes if you got your arm in the way, you might lose signal between the two. And now we're talking 1,000-foot range or something like that on the Bluetooth sometimes, and we can get much farther, which
Yeah.
is why they chose to go with Zigbee, because Zigbee was a mesh network where you could put any of the probes, no matter where you put them, they would act as their own relay back to that base unit, and then the base unit was Bluetooth to your smartphone.
Right. And thanks for that. I would have to check on the exact timing of that, but I think it's sort of like clarifying that Testo had what they called the sticks,
Uh huh. Okay.
humidity stick, thermal anemometer, pressure
Yeah.
probe. Those are all very compact single sensor systems,
Hmm.
and then they evolved pretty quickly, and it might have been stimulated by the interest caused by iManifold to smart probes, so
Hmm.
that they took the display out and turned them into. Again, anybody listening from Testo, iManifold, wherever,
Somebody will set
can
us
correct
straight
us. Yeah,
someday.
yeah,
There was a massive amount of iteration going on in that, from the basic digital manifolds, which started I I think the first digital manifolds came out in maybe the 1990s, and there was the first couple manufacturers had a lot of problems with their sensors, as I recall.
Yeah, I think it was the late 90s.
And then Doug Lockhart and
Digicool.
Digicool were really the ones that kind of pioneered a really good quality digital manifold.
Yeah, talk about product development, and you know this. Just he would hammer the housings on videos to show people
Oh,
how rugged they were.
he had a picture on his website. I still remember seeing that, and it was one of the things that made me buy it. Like he parked a truck. He
Yeah,
literally went out in his driveway, laid a case down, and parked his Dodge truck on top of it, and
yeah,
took a picture of it. And like that's tough, and he built that to be tough. I mean,
yeah,
it was maybe overkill for a lot of situations, but they were hard to break.
yeah. And he's a contractor with a great idea,
Yeah.
and set about being very inventive, and set about making products.
He did. He made a lot of products and some high quality ones.
Yeah,
There was a lot of
absolutely.
products.
Very, very, very rugged. I mean, I think, if you want to look at what stood out was the ruggedness and also the innovation. It was really the first one out there. When again, my recollection, Testo got into digital manifolds when they bought a company from the former East Germany called Acdor, Acdoor, that was making units and extruded housings. Um, Dizzy Dallas is watching.
Hey, Dizzy.
Honeywell made one of the first digital manifolds.
Huh. I don't think I've ever seen one of those.
Yeah,
Hmm. I'll have to I'm gonna have to go do some Google searching afterwards.
yeah,
Put my Google fingers to work. Anyways, we kind of got off on a side tangent there,
yeah.
but that's okay. That was fun. And digital the wireless digital products, I think over the past probably 15 years have been just an amazing development speed
Mhm.
to me. And they've evolved really well, I think, for the industry because they allow us to get information. Like that was one of those things that it was industry changing, because it allows us to bring all that information to one place in real time, right in front of us. And now, with the various apps, Measure Quick or the manufacturer, Testo, Field Piece, UEI, JB, they've all got their own version of the app, but it does so much of the math for us in real time
Yeah,
that allows us to be more efficient with our time gathering and analyzing data, doing basic data analysis that we can then do other things, maybe spend some more time with the customer, asking questions, answering questions, and communicating with that customer or something like that. Um, so that's a good, interesting product development
yeah.
timeline right there. How quick those developed. Because being this is my 20th year in the industry this year,
Wow.
and I think I got my first Digicool. Digicool was already in the industry when I came in, but I think I got my first Digicool like maybe my second year into the industry. And I still have it today and it still works.
Nice.
I can go throw a battery in it right now. And last time I had a battery in it, I put it on a tank of refrigerant and checked it, and it's just as accurate as the day I bought
Yeah,
it. So that's one thing that I think is pretty neat about the digital stuff is it holds its accuracy much better,
yeah.
um, in my experience, anyhow. So, anyways, back to our originally scheduled programming.
Sure. So you've got pilot production going. You got quality control, um, and market launch, product launch to the market. Uh, I like to think of my experience tells me to think about the marketing strategy as you're developing the product concepts. At least whiteboard it, because that's going to be the things that differentiate it are going to be the things that help sell it. The things that customers comment and feedback on are going to be the things that you want to use to promote the product. And you also have to think about the distribution strategy, and that's where some of our, the stimulating conversation we had is, have you thought about distribution? Like, can you make and sell enough of these to make it viable? Or do you need to have it sort of amplified through another channel? And when you do that, you have to build in a cut for the distributor.
Hmm.
Otherwise, the distributor has no interest in working for you. Um, so, and then when you do get to, even, customer training, customer support, but if you do have distribution, it's training distributors. And that's something we like to try to do more and more at TruTech, is get some kind of training from our manufacturers, so that we can speak intelligently, be that first line of support, because everybody's always going to need some kind of support.
Yeah, I mean, there's I don't think any product ever been made out there that didn't need some sort of support at some point in time.
Yeah,
And the more complicated they get, oftentimes the more support they need. Sometimes not, but often. So, what does field testing look like? And let's see, and then I've got a kind of another concept I want to talk through with you too. But
sure.
when you talk about testing something, obviously we want to get it out of the laboratory. We want to kind of a proof of concept. Does it actually work? But then we need to get it out in that field and say, not only does it work, but does it work for the people that are going to use it every day?
Yeah, is it valuable?
Right.
Does it offset some other cost? I mean, it could be the cost of time, it could be the cost of callback, it could be the cost of your reputation. So there's a lot of costs that are involved. So, and it has to, if it becomes so integral to your work that you have to rely upon it, it must be reliable. Otherwise, you're building on a faulty foundation.
Yeah.
So, reliability testing and that early pilot production is going to give feedback. Have you been involved in any pilot products? Gotten your hands on pilot products?
A couple.
Yeah.
Yeah, a couple. Not mostly in the what would be considered the beta testing phase.
Okay.
Um, but not anything, not too much before that. Like I've had a couple in my hand, but nothing real, real in depth.
Yeah. And then there's sort of I wouldn't say the danger, but if someone's taken a product so far along and they're not really beta testing, they're giving you the finished product, their ears and eyes may be closed to feedback.
Hmm.
So if they missed the boat, it's important for the beta testers to let them know,
Yeah,
even if it's too late.
yeah. Well, because at that point you're still not producing it. You're not trying to sell it yet. If there's major flaws or major problems, you still don't want that to go out to the marketplace,
Yeah,
because if you get, and that's a really important thing to consider, if you get a bad name in the marketplace with a product, um, people tend to lose trust in later products that you have.
sure.
Um, I can think of a couple
Yeah.
that I've had experience with that I still look at and I'm like, hmm.
Yeah, and the ability to quickly react to updates, necessary updates, and even to the point of recall. Um, I'm not going to say who, but um, in my long career of experience, a manufacturer really just inadvertently picked the wrong material that a refrigerant actually ate through the material, and it was supposed to be contained.
Mm,
I'll leave it at that. That was a big faux pas,
yeah.
um, and caused a recall of a few hundred units.
Hmm. Yeah. That would be a massive problem.
Yeah, yeah, but they handled it well. Understood what was going on. It was sort of like uh, it may have been, I don't know exactly, but a miscommunication or a misunderstanding. So there's this handoff process, and I'm sure Rachel's very familiar with it, handing off at different stages of development all the information, or having colleagues interacting with you through the development process as they're getting ready to receive it to take it to the next stage. Because it
Hmm.
is not often that the same team takes it all the way through all these stages that we've discussed tonight. So it's the appropriate handoff, the cautions, the reasons why decisions were made.
Yeah.
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 So
Because a lot of times the team that develops the concept is not going to be the same team that develops the manufacturing process. And that manufacturing team has to take that concept and then develop that into a manufacturing process that is easily repeatable, or as easily as possible repeatable, over and
and
over and over
I
again
don't want to
for
blame manufacturing engineers, manufacturing personnel, but it's like, oh, I got a great idea. We can make a cheaper buy. And if they don't know that that buy relates to something that was built in because of a certain reason beforehand, uh-oh, they're
yeah.
in trouble.
Well, and that goes to that term, it's I get a little scary when I hear it. It's called value engineering.
Mhm.
And sometimes it engineers the value out of the product
Yeah,
if it's not done well.
yeah.
Value engineering, the idea is to make it as inexpensive as possible, but still do the job. And sometimes that can go a little bit beyond where it should stop.
So I watch a little of, Sandy Munro, his YouTube video. He does
He's a lot of fun.
He's a lot of fun. So, if you look it up, Munro,
Hmm.
Sandy Munro, uh, he has a automotive design consultancy, I'll say, but his one of the big things he does is tears down products, vehicles, and looks at how they're built and why they're built a certain way and analyzes it and gives you a very, raw opinion. It's great to listen to. And now I see he's got more of his team, his colleagues are doing more of these videos. But one of the things that I glean from that is I believe he's a big fan of the castings that Tesla is using to make their vehicles, because you can eliminate putting equipment together by welding or bolting or other forms of fastening or even gluing. You can put in places to mount things, holes, fixtures, unusually shaped parts can be made in these large casting, and they just come in, boom, there's one thing. And I like to think of castings are like they're grown like bones,
Hmm.
because they have they're the same material that's flowed throughout this whole casting assembly. But that's a place where value engineering. Now, you get everything like ready to rock and roll, but what's the tooling that took to get you to make that casting?
Oh yeah, there's a lot of work that has to go into making that casting and then machining that casting in all the different bolt holes or mating surfaces or whatever to get everything to line up, because you're not just talking about two
Yeah,
surfaces or 2 points, maybe two bolts, a bolt on both one end or the other. Now you might be talking about 20 different surfaces all coming off of a single piece, and they all have to be aligned and meet each other, and
yeah.
that can become really challenging. But it's also become easier with the manufacturing technology that we have, like the multi-axis CNC machines
Mhm.
that can work in multiple planes and on multiple surfaces while keeping that product contained in one spot, but rotating the product or rotating the cutting heads.
Yeah, and if you think about like even mechanical manifold for refrigerants, um, there there's different passageways in there, and
Mhm.
there's cross drilling that has to be done to be able to flow the refrigerant through the 3 or 4 ports as necessary.
You know what? I got one. I've got one hanging on the wall over here.
Okay,
Let me go grab this.
all right.
I'm gonna be right back, everybody.
You weren't that long. I was going to play music.
Oh, you're gonna play music.
Yeah,
So do you remember these?
sure. That's the Sherman manifold because it's built
Yeah.
like a Sherman tank.
It's heavy as a Sherman tank
Yeah.
too. I'm gonna tell you what, that whole so that's a DigiCool for those of you who haven't seen one. That's a I don't remember what model, but anyways. So that was a concept manifold that it had a lot of problems in the actual valves, um, actually getting the valves to seat. And it was never put out. I don't think it was ever put out for production.
I really can't remember. That was like the early days of TruTech. That might have been 2008, 2009. Jim
Yeah,
Bergman probably remembers very well
yeah.
because I think
But
he and his dad helped engineer that.
it was one of the so it's actually got a see-through sight glass. If you look at it, you can see my finger back there, so you could see the refrigerant in there really well. Um, it was a really innovative, based on the other manifolds that were on the market at the time. It was a really innovative manifold. Had the front hose parks on it. This was something that a bunch of us at the time really advocated for across the industry
Mhm.
because we were like, why do I have hose parks on the back of a gauge when I don't need to take the hoses off the front? I need to get the hoses off the back then to hook them up. Why
Right.
am I
Accessibility. Yeah.
Yeah, why am I messing around with this on the back of it? Let's put it on the front, and then it can hang against, like, this one actually has magnets on the back of it. I forget who gave this one to me. Somebody gave that one to me. But that was part of the old thermal engineering company.
Yep.
They were the one that did all the machining on that. But yeah, so this had a number of, like, the holes here. That's why these side pieces are actually on an angle so that the hole for this could be drilled down in here. And then there was a cross drill hole that went all the way through the whole center of the manifold that connects to the holes that come up from the bottom where the refrigerant passages connect to, and then the holes on the top that connect through constantly from the port down here up into the gauge so that the gauge always sees pressure, whether this valve is open or closed. There you go.
The Bronze Design Dealer Award for
Yeah.
the collaboration with TruTech, DigiCool, and Thermal Engineering for
What
the
year was that?
that was 2009. Yep, July 2009.
There
So
we
we
go.
actually have the award for this in the TruTech office on our little award shelf inside the lobby.
Huh. Yeah, it was a great idea at the time. Unfortunately, like I said, those valves were as I recall, there was some issues with those valves seating, and then the production cost, I think, was really high on it.
Yeah. So
But
uh, uh,
that was one of the beta models that went out.
yeah. So, and I'll say something else, and this is like no slight against anyone, but sometimes you can apply for awards, and the product never sort of sees the light of day. It's more
Yeah.
about concept. So again, not slamming anybody about awards, but personal experience, this one really um, didn't go very far. I mean, the core, the digital refrigerant analyzer, the Digicool, that was a solid product, but it needed a manifold. The
Yeah.
idea was you brought along your old manifold. You know, the TruTech kitting concept was, hey, let's sell it with a manifold, but let's make a better manifold right there.
Yeah. So this one, this is actually two separate pieces on this particular one. The head unit is all its own. And it actually came when you bought them new, it came with 4 right angle fittings that you could adapt that head onto any manifold.
Yep.
So it looked kind of funky and sat up a little higher rather than that straight through connection, but it worked really well. And you could put it on any manifold, 2 valve, 4 valve, whatever you wanted to. So
Yeah.
it's kind of a neat idea. So
Uh,
we kind of scheduled this for an hour, and we're getting towards the end of
yeah.
it here. I had another thought, and now it's escaped me because we went down another rabbit hole, actually showing a product and kind
Yeah.
of given that idea of concept. But it shows that a really good idea, once it got out into the field, and I'm trying to remember because I was part of that group that beta tested that. I want to say that it was an expansion and contraction issue.
On the Sherman.
Yeah,
Yeah.
because the valve, when the refrigerant went through it, and that metal would get cold, and it would slightly change shape, and it would cause that valve to not seat properly.
And think of the thermal mass there.
Yeah, there's a ton of thermal mass in that manifold because that was a solid block of aluminum to start with.
Right.
Um, and it would get cold really fast.
Yeah.
So it's one of those design features that we don't think much about. And there's some brass in there too, because a lot of the valves are actually have brass parts in them.
So two things I want to do before we end. One is encourage people, if they can, to go to the AHR Expo, because there you can pick the brains of product development people.
A lot of times,
They'll
absolutely.
be right there because they want to hear firsthand, and they're very proud of presenting the new products. I remember specifically spent a lot of time this year at the Yellow Jacket booth with a product development guy who's forgot his first name. Was it Grant or Glenn? I'm sorry, whoever you are. You were a tall guy from Minnesota, so you look like, I can't remember you, but thank you for being there. The other thing to keep in mind is right before the HR Expo, which is in Orlando in 2025, is going to be what's happening the weekend before, Eric.
Oh man, what is that? What is that thing
Hmm.
down near Orlando? Oh, the HVACR symposium
Oh yeah,
by
yeah.
HVAC school. It's even on your shirt. HVAC school, right there on your shirt.
Oh,
Over
sorry.
there, yeah,
Yeah,
over there.
yeah.
And who who's sponsoring that this year?
This year, the title sponsor is TruTech Tools.
Yeah.
We're very proud
Woo.
to have that position. And again, you want to learn about product development, and there'll be people there too at the symposium who are product developers or very close to that. You
Mhm.
can pick their brains a little bit too.
Yeah.
And I think I enjoy this conversation. I'm really glad we had a chance to do this. And I did very, very little prep work. I printed out a couple things, but I just thought I would riff, and you were the perfect interviewer for this, Eric. Thank you.
Well, thank you. I mean, it's a lot of fun. And sometimes riffing is the best thing that can happen because
Yeah.
you just squirrels you find a squirrel hole and you head down it.
Yeah. Cool.
Well, thanks everybody for joining us tonight. There were quite a few people in and out, it looked like, but hopefully this was useful to somebody out there. Don't let this scare you away from designing things. Please let this encourage you and maybe educate you on what it takes to really get that product out to market.
And there are some manufacturers who do accept ideas
Yeah.
and will engage you in the profits for the product. I don't have them at my fingertips now, but it never hurts to ask.
Yeah, and talk to manufacturers, even if they don't have a formalized program. A lot of manufacturers, if you have a good idea, have it written down, and if you want to be involved, or if you just want to hand them an idea and say, "Here, go make this to make my job easier," a lot of manufacturers will listen and get you involved or get your feedback on things. Maybe you can be part of the testing team, however you want to do it.
Yeah.
I've seen some people just give their ideas away, and some people they want to manufacture it themselves or be involved. It just depends on your desire for level of involvement
And stress.
and stress, because product development can be very stressful. I've
Yeah, it
seen
can.
that, especially if you're starting out on your own. Because and one of the things we really didn't even get into test or talking about is laboratory testing for accuracy and things like that,
Yeah.
and testing things as they're going out the door to make sure that they're accurate, which is a pretty big thing in our industry because we as technicians live and die by those readings and the accuracy of those readings coming to us from our instrumentation.
Yeah. That's very, very true. And then the references or the standards you need to check something against has to be a higher level of accuracy.
Mhm.
So that costs a lot more or requires special conditions to maintain it. So
Yeah, and yeah, conditions to maintain it, which is extra cost over the long time too. So you have to factor in, that's other costs that you have to factor into the design and the sale price of it.
well,
So
hopefully for all you out there, we did this topic justice and open your minds to a little bit to product development. Is it easy?
maybe depends on who you are and what you consider easy.
Yes.
Some people might be like walking down the street chewing bubble gum, but
Yeah.
some people, it's going to be a little bit harder for you. But anyways, Bill, thanks for joining me tonight. I appreciate
Absolutely.
it. It's a
Yeah.
lot of fun. And, I've got a bunch of other topics in mind for this, but any of you watching out there, if you think of something that you'd like to see us talk about or go into in depth on a live stream sometime, um, we're going to try to do them about once a month. That
Mhm.
may or may not happen all the time, depends on our schedule because we do a lot of traveling and going to different shows and events and things like that. But shoot us an email, shoot us a message, something
Yep.
like that.
E.
We'd
Kaiser, TruTech Tools, Bill at
Yep.
TruTechTools.com. Yeah.
Yeah, exactly.
All
Thank
right.
you.
Cool.
Good night, everybody.
Good night.